Right, hey everybody. Now we're going to solve some equations that have square roots in them. Vocabulary to get out of the way. So a radical equation is an equation in which the variable is in the radicand. So in other words, the variable is underneath a radical. Just this one. All right, so we've got um, the square root of x plus 2 is equal to x. And the question says, is x equals 2 a solution? Well, how do you check to see if something is a solution? Well, you substitute that value in for that variable and you see if it creates a true statement. In this case, we're going to substitute 2 in where we see x there and there. So there's two places we're going to put a 2. All right, and we're going to see if it gives us a true statement. So the square root of 2 plus 2, is that, I'm going to put a little question mark above that, is that equal to 2? So I've got the square root of 4 is equal to 2, and the square root of 4 is 2, and 2 does equal 2. So we would say yes, this is a yes or a no question, okay? So now they also ask us, is x equals -1 a solution? So we're going to put -1 in here, and we're going to see if it creates a true statement. All right, so we've got the square root of -1 plus 2. Is that equal to -1? So -1 plus 2 is 1. And whenever we have a radical here, we are really looking for the positive of this, okay? So we want the square root of 1, which is 1, and does 1 equal -1? No, it does not. So we would say no to this one. So there's some steps here to how to solving a radical equation. So it says here, step 1, we want to isolate the radical on one side of the equation. Step 2, then we square both sides of the equation. We solve the new equation, and then we always check our answer. This step 4 is the place where most people decide that they will save some time, and it is a bad call. Okay, the reason why it's a bad call is because with these types of problems, it is very, very possible to get an extraneous solution. And you should know that extraneous solutions happen whenever we do great math, but we get an answer that just doesn't work, okay? And you're going to see some of that as we go through some of these examples. So never, ever, never skip step 4. All right, so for this problem, we're going to follow those rules, and the first thing we're going to do is we are going to square both sides. Now, remember back from one of your previous lessons, whenever you were first learning about radicals, that this right here, the expression is underneath a radical, that can also be written like this, right? So this and this are the same thing, right? Okay, so that's the reason we're squaring it, because check this out. What do you do when you have a power raised to a power? You multiply the powers together, okay? And what is 1/2 times 2? It's 1. So that leaves us with just 2x minus 1 on the left-hand side. And don't forget, you also need to square the other side, okay? So whenever we square 7, we get 49. Okay, now we need to solve for x. So let's add 1. 2x is equal to 50. Divide by 2, x is equal to 25. And what did I tell you guys? I told you always, always, always check your work, okay? So we're going to check it. I'll do that in a different color. So we've got the square root of 2 times 25 minus 1. Does that equal 7? So 2 times 25 is 50. 50 minus 1 is 49. Square root of 49 is 7, and 7 does equal 7. So we know that we have the correct answer here. Always check your work. All right, so what about this problem? So again, Step number 1 says to isolate your radical. So we want to add 9 to isolate the radical by itself on the left-hand side. So we're left with the square root of 5n minus 4 is equal to 9. And we're going to square both sides to get rid of the radical. So that 2 gets rid of that radical. So I'm left with 5n minus 4 is equal to 81. I would add 4 to both sides. And then I would divide by 5. So n is equal to 17. Okay, now in order for this to truly be the answer, you've got to check your work. Okay, so let's take this 17 and we're going to substitute it in everywhere we see n. Go back to your original problem. Do not use any version that you have created with your own handwriting. The reason why I say that is because it's very possible to check an answer, and if you made a mistake somewhere up here early on, then it's very easy for you to think that you have the correct answer there, okay? So go back to the original problem every time you check your work. All right, so I've got the square root of 5 times 17 minus 4 minus 9 equals 0. Okay, so I've got the square root of 85 minus 4 minus 9 equals 0. 85 minus 4 is 81. Square root of 81 is 9. 9 minus 9 is 0, so I've got 0 equals 0. That is a true statement, so we know that that is the correct answer. Right, so what about this problem? It looks like we already have a number over here. It's not 0. That's okay, totally fine. We can still do the same thing that we've been doing. First, we're going to subtract 2 from both sides. And now we're going to square both sides. So this 2 cancels that radical, so I'm left with 3y plus 5 is equal to 9. Now we're just going to go ahead and follow through. And we're going to divide by 3. So y is equal to 4/3. Okay, so that's okay to get a fraction. Let's check it. Let's check our work. All right, so we're going to put 4/3 everywhere we see y. So I've got the square root of 3 times 4/3 plus 5, and then the outside of the radical, we've got plus 2 equals 5. Check this out. The 3's cancel. I'm left with 4 plus 5. So I've got the square root of 9. Square root of 9 is 3. And 5 equals 5, so we did good. This is our correct answer. Okay, so it's really important that you understand that whenever we see a radical, we are talking about the principal or the positive root, okay? So whenever we take this square root, we are talking about the positive of this. So watch what happens whenever we continue with this problem right here. So check this out. If I were to take the square root of this, there is no number that whenever I take the square root, I get a negative number, okay? So this would actually have no solution. So k is equal to no solution. And I can actually tell that without going any further because the number on the other side of the equal sign is a negative number. All right, so I just want to point out, this is something that people tend to forget, it happens all the time, is that whenever you square a term, or an expression, I should say, that you end up with this binomial squares term like this, okay? If there's a minus, then your middle term will be negative. But keep in mind that when you square, let's just say x plus 2 quantity squared, you don't end up with x squared plus 4, okay? That is wrong. You end up with x squared plus 2, there we go, 4x plus 4. There is a middle term on these, okay? So do not lose your middle term whenever you are squaring a binomial. Here's an example of that. And I put this on here this time, but I will not always remind you to not lose your middle term. So it's something that you do need to get used to, okay? So for this problem, we would subtract 1 from both sides. Okay, so I'm left with the square root of p minus 1 is equal to p minus 1. And now I want to square both sides. Okay, all right, so this cancels that. I'm left with p minus 1 on the left. And just off to the side, I'm going to do p minus 1 times p minus 1. I won't always show this part to you. Just for the sake of time, but I want you to know that this is what we're doing, okay? So we've got p squared minus 1p minus 1p plus 1, and then you combine your like terms there. So p squared minus 2p plus 1. So on this side over here, it becomes this right here, p minus 1 quantity squared, turns into this trinomial. Okay, now we're going to bring everything over to one side. We're going to solve for p. So I'm left with, I'm going to scoot this up, 0 is equal to p squared minus 3p plus 2. And this thing factors. And now we're going to take each of these parentheses and we're going to set them equal to 0 and we're going to solve. Okay, so now we have two solutions that we have to check, right? So let's go ahead and do that. Go back to your original problem. We are checking our work here. And I check each one of these values individually, all right? So the first time I'm just going to check the p equals 2. So I've got the square root of 2 minus 1 plus 1 is equal to 2. Let's try that out. Okay, so 2 minus 1 is 1. I've got the square root of 1. Square root of 1 is 1. And 1 plus 1 is 2. So we know that this one checks out. That's a great answer. All right, let's try the other one. The square root of 1 minus 1 plus 1. Does that equal 1? Square root of 0 plus 1 equals 1. Square root of 0 is 0. And 1 equals 1. So this is also a great answer. It's okay to have two solutions here. All right, so what if you have a number that's in front of the radical? Oh, let's see here. Let's see what we're doing. All right, so the first thing I would do is I would move this 8 away. Now, here's the thing that you need to remember is that you can do one of two things here. You can go ahead and divide both sides by 3. That would work, or you can do it this way. But when you do that, you have to remember that this 3 is also being squared. So 3 to the second power is 9, and we are multiplying it times what's inside the radical. Okay, so then we would distribute. I would add 45 to both sides. And then I would divide by 27. So on my calculator, I'm typing in 189 divided by 27. So x is equal to 7. All right, again, you have to check your work. All right, you have to. I know you want to save time. I was there. I was a student at one time. I get it. It's not really saving time if you get the problem wrong on a test, though, I promise you. So 3 times 7 is 21. 21 minus 5 is 16. So 3 times 4, once you take the square root of 16, you drop the radical. So I've got 12 minus 8 equals 4, and I've got 4 is equal to 4. That's a great answer. We did good. So what if you have radicals on both sides? It looks harder, but it actually isn't. This one's actually easier than the last one we did, I feel like. So we're going to square, and guess what? This 2 gets rid of that radical, this 2 gets rid of that radical. So you're left with 4z minus 3 is equal to 3z plus 2. So then I would subtract 3z. I always grab my smaller variable term and move it. So I've got z minus 3 is equal to 2. I would add 3. So I've got that z is equal to 5. So see, it's actually an easier problem. Again, to check, go back to your original problem though. So the square root of 4 times 5 minus 3, is that equal to the square root of 3 times 5 plus 2? So this is 20. 20 minus 3 is 17. So I've got the square root of 17. That's 15 plus 2. So I've got the square root of 17. Although I can't easily do the square root of 17 in my head, I really don't need to because the left side is identical to the right side at this point. And I know that this is a good answer because the left side is identical to the right side. All right, so sometimes after you square both sides, you still end up with a radical, and that's okay. You have to keep repeating step 1 and 2 until you get rid of it, okay? And I'm going to show you why. So for this problem right here, there's no way to isolate the radicals by themselves, okay? Even if I were to move this square root of m over here, it actually creates an even bigger mess for the radicals. So let's not do that. So watch what we are going to do instead. We are still going to square both sides. Okay? Now, when I square this right here, let me show you what I mean by that. All I'm doing is I'm squaring this first term. So I'm going to write it out. So square root of m plus 1 times the square root of m plus 1. Now I'm going to go ahead and use the distribution property. So square root of m times the square root of m is the square root of m squared. Square root of m times 1 is 1 square root of m. You don't have to put the 1 out front. It's understood to be there, but it helps sometimes to remember that you need to add your like terms together. So then we're also going to do that right there. 1 times the square root of m, also 1 square roots of m, and then 1 times 1, which is 1. So now this becomes m. These guys right here become 2 square roots of m, and I just brought this plus 1 down. Okay, so that's the left side. The right side's easy. That 2 gets rid of that radical, and I'm left with m plus 9. Okay? Now, I'm going to isolate my, my radical now. So I'm going to subtract m, and I'm going to subtract 1. So subtract m, subtract 1. Okay? This goes away, this goes away. On the left side, I am left with 2 square roots of m is equal to 8. Okay, because m minus m is 0, goes away. All right, now I'm going to square both sides again. And remember, if you square this whole thing, you've also got to square the number in the front. So I've got 4, and then I've got times m. Okay, because remember that 2 got rid of that. So 4m is equal to 64. Divide by 4, m is equal to 16. Again, check your work. It's super important. All right, so we're checking. I'm going to go back to the original problem. I'm going to erase some of this stuff up here so that I can actually see the original problem. So I've got the square root of 16 plus 1. Is that equal to the square root of 16 plus 9? So I've got 4 plus 1. 16 plus 9 is 25. 4 plus 1 is 5. Square root of 25 is 5. Look at that. Great answer. All right, so this is probably about as tough as they're going to get. And it's really easy to lose things with this. So if you are a person who does not write things out, this is why we teach you to write things out, because it's very, very easy to lose things with this problem. All right, so again, I cannot isolate the radicals. So I'm just going to square both sides. So this right here turns into the square root of q minus 2 plus 3 times the square root of q minus 2 plus 3. So what I would do here is I would distribute this times this. I am left with square root of q minus 2 to the second power. Okay? Now this times this, I have plus 3 square roots of q minus 2. Right here I have plus 3 times the square root of q minus 2, and then 3 times 3 is 9. Equals, remember this 2 just gets rid of that radical, so I'm left with 4q plus 1 on the right. All right, that's the easy one. All right, so this 2 and this radical go away, so I'm left with q minus 2 plus 6 times the square root of q minus 2 plus 9 is equal to 4q plus 1. I'm going to combine these like terms right here and here, okay? So I've got q, I just brought this straight down, q plus 7 plus 6 square roots of q minus 2 is equal to 4q plus 1. Now I'm going to move anything that doesn't have a radical from the left side to the right side. So I would subtract q here, subtract q, subtract 7, subtract 7. That goes away, that goes away. I'm left with 6 square roots of q minus 2 is equal to 4q minus q is 3q minus 6. 1 minus 7 is negative 6, so that's where this comes from. Now I'm going to square both sides. Squared, squared. Okay, don't forget, you also have to square this 6. So this becomes 36. And this 2 gets rid of that radical times q minus 2 is equal to. Now remember, if it helps you, write this out. There will be a middle term. So I've got, let's see here, 9q squared minus 36q plus 36. Okay, I need to distribute this out. And now I'm going to move everything over to one side. I'm left with 0 is equal to 9q squared minus 72Q plus 108. All right, now I'm going to factor out a 9 because all three of these terms actually have a 9 in common, and I'm running out of space here. Okay, forgive me, I'm going to scoot this over. Nope, it won't let me. So I'm going to go up here. So I've got this thing factors to b, q minus 6, and q minus 2. Now, 9 will never equal 0, so I'm not even worried about this 9 out front. So this gets set equal to 0, and I solve. This gets set equal to 0, and I solve. Okay, so I'm going to do q minus 6 is equal to 0, q minus 2 is equal to 0. So q is equal to 6, and q is equal to 2. So these are our two answers, and remember, you have to check your work, okay? So 6 and 2 are our solutions. You would go back to your original problem. I'm going to erase some of these marks up here so that I can see. And I'm going to write the answers up here. So I've got q is equal to 6 and 2. And we're going to try both of these solutions out. I've got a little bit of room right here. So I've got the square root of 6 minus 2 plus 3. Is that equal to the square root of 4 times 6 plus 1? So I've got the square root of 4 plus 3, and I've got the square root of 24 plus 1, which is 25. So I've got 2 plus 3 is equal to 5. Yep, 5 equals 5. We did good. So 6 is a good answer. Now you have to try out 2. So the square root of 2 minus 2 plus 3, is that equal to the square root of 4 times 2 plus 1? That's 0. Square root of 0 is 0, so I've got 3 on the left-hand side. 4 times 2 is 8. 8 plus 1 is 9. They are both great answers. So we tried them out, we checked our work, and we did good work. All right, I hope this helps you, and let me know if you have any questions.